Hello friends, in this video we are going to learn Wistron motherboard power sequence. We have seen different power sequence, like we seen Compil, Quanta, Foxconn, Inventec. But in this particular video we are going to learn a Wistron motherboard power sequence. Wistron have their unique power sequence. Okay, so first thing is how we'll find whether it is Wistron or Compil or Quanta is that the Wistron motherboard number, the number normally start 5 digits like 1, 2, 3, 4-1 or something like a 5 digits and -1 or -2. That is a main identification for the Wistron motherboard. Okay, and if you'll find this 5 digits and -1 or -2, then you will come to know this is a Wistron motherboard. And Wistron motherboard is normally used in Dell laptops and in Lenovo laptops. So if your laptop is dead, it's not powering on, it's a next generation, like it's a 5th generation onwards, then you have to follow these steps. I mentioned here a very simple steps, so I given you a number, so you just simply follow all this number. Okay, and if you follow this number, then 100% you can able to diagnose the problem in the motherboard. If the motherboard is not powering on, then simply follow this number. So I'll introduce this number, this thing first. This is a CPU, this is combined with the PCH, this is a SIO. Normally in Wistron motherboard, SIO is normally by the Newton. Okay, and these are the different buck converters. Like this is always voltage, 3 volt and 5 volt section. It's called the always voltage. This voltage supply start before power button press, so that is why it's called the always voltage. Then this is a 1.35 voltage for the RAM. If it is a DDR3L, then it's a 1.35, and if it's a DDR4, then 1.2. This particular section generates the two voltages. One is called the VDD-Q and another is a VTT. The RAM require basically a 3 voltage, that is a VDD, VTT and SPD. So here we are considering our RAM is a DDR3L. Then this RAM DDR3L require a 1.35 voltage and VTT is 0.67 voltage that generate by this section. So these are the buck converter, right? Then is require 1.5 voltage, then the 1.05 voltage, and the finally CPU core voltage, right? Here is my bias. Okay, and this is a SIO. Now when I connect the adapter or the battery, this is not the voltage section, adapter input and voltage section. It's called the battery charging section. And what this battery charging section do is, once he receive the current from the adapter, he pass this current to the next section, so that my current will come here. And here this green component which you are seeing, this is a current sensing resistor. So this is a current sensing resistor. You should get here the adapter voltage. Okay, this is step number 1. And if the voltage is not coming here at this point, that means at this current sensing resistor, then problem in this voltage section. So you have to go back and trace this section, why this voltage is not coming here. So this is our first test point. Here we have to check my voltage, and how much voltage will come here. Here the voltage will come, whatever the adapter voltage is there, that voltage will come here. If the adapter voltage is 19.5, then here you will get a 19.5 voltage. Okay, so this is a step, and this voltage will travel to this buck converter. It's a different buck converters, to this 3.5, 1.35, 1.5, 1.05, and finally it's CPU core. But all this section doesn't respond, because they will respond only and only after they get the enable signal. Otherwise they don't respond. Only this section will respond, because these sections have totally 4 sections, 2 linear regulator and 2 buck converters. 2 linear regulator generate VRG3 and VRG5. This is called a voltage regulator 3 and voltage regulator 5. But before that, SIO need 2 more signal, that is EC reset. SIO require this EC reset, that is a 3 volt. SIO require this is a 3 volt, and SIO require this is a 3 volt AC in inputs, and SIO require this is a 3 volt at the VCC pin. So SIO need a 3 signal, AC in, EC reset and VCC. Okay, and once he received all this signal, here you will get a 19.5 volt. Okay, this voltage will coming from battery charging section, and this 3 volt will be come from always voltage section, and volt in and battery charging section send one signal, that is the adapter current present. AC in means the adapter current, that means AC adapter in is informing that the adapter is present, that is generate a 3 volt here. Okay, and this is called the EC reset. EC means the embedded controller. In electronic, every chips require a reset signal to clear all the junk information within the chips. So every chips require a reset signal, and reset signal is normally a 0 volt. If we give a 0 volt to the any embedded controller or the PCH or the CPU, it get reset, and then to come out from the reset state we have to increase that voltage. So the SIO first get a 0 volt and it's come back to the 3 volt. Now our all pins are 3 volt, like a VCC get a 3 volt, AC in is a 3 volt, EC reset is a 3 volt. Then if it is my SIO is okay, then the SIO will generate this signal. It's called S5 enable. SI will generate this signal S5 enable, and this signal enable to my this buck converter, always voltage buck converter, and once it's given enabled to this buck converter, this buck converters start pulsating to the MOSFET and generate a 3 volt and 5 volts called a 3.3 always and 5 volt always, and this 3.3 always is going to the CPU, and this voltage is called VCC DSW. The VCC DSW is a VCC stand for the voltage, DSW stand for the deep sleep wake up. So CPU, once the CPU get this voltage VCC DSW, that deep sleeps wake up, then the CPU wake up from the sleep mode. Okay, so this is step number 5. But before that, SIO need a 2 more signal. Once is need RTC VCC. This is a CMOS battery, is need this 3 volt RTC VCC. So here you should get a 3 volt, and the next signal he need a RTC reset. Here also he need a 3 volt. Then only the CPU will respond. Okay. So if you have laptop is dead, it's not powering on, it's not responding SLPS3 and SLP4, then what you have to do is you have to check VCC DSW, RTC VCC and RTC reset. Okay, so these three signals are very important. So this is a step number 5. Okay, step number 6. And then what the SIO will do is SIO send this signal RSM RST. Step number 6, RSM RST. Right, this is a very important signal, and this signal also a 3 volt. Here is a binary logic, so don't worry about it. So only you have to check a 0 volt and 3 volt. Okay, so 3 volt will send out by the SIO to the CPU's RSM RST, means the resume. It is saying to the CPU that you start resuming the work. It's called the resume and reset. And once he get RSM RST, he generate this signal is the SUS clock. SUS clock is some oscillating pulses like this. It's the frequency something like a 32.7 kilohertz, and this signal you can check by using an oscilloscope. You can't check the signal by multimeter, so you have to use oscilloscope, and oscilloscope will show you a 32.7 kilohertz frequency. So this is called the SUS clock. Okay, so this is step number 6.2. The next is, once now our laptop is on standby mode, we are not yet pressed the power button, so it's a preliminary, every components are ready to work. So now everyone is waiting this step number 7. It's called the power button. In laptop there are normally 2 power buttons called KBC power button or NBS power on or power button or on off switch. This is a primary power button which the user press, and here is a 3 volt, right? But when we press the 3 volt, it goes to 0, and when we release that button, it's come back to 3. That means a 303 pulse will be generated at the step number 7. So once SIO get this pulse, 303 pulse, then the SIO start working, and then at step number 8, SIO send here the PM power button, the post power button, the step number 8. It's called the PM power button or the post power button. Post power button also generate a pulse, that is a 303 pulse will be generated, and it's given to the CPU, informing that power button is pressed. Now CPU has to respond. How the CPU will respond? CPU will send 2 confirmation signal to the SIO in saying that turn on all the buck converter one after another. Basically, what is a power sequence? Power sequence is nothing but a sequence of voltages, that is turn on one after another, and final CPU core voltage will turn on. So this is called the power sequence, and all power sequences are little different, and here we are talking about the Wistron power sequence, right? So once the CPU get this step number 8, that PM power button, then CPU send out a 2 signal. It's called SLP underscore S4 and SLP underscore S3. SLP means the slip. There are in laptop there are 3-4 power steps. Let's call S5 states, S4 states, S3 states, and S0 states. S5 states means the standby voltage, S4 states means the RAM voltage is on, S3 voltage means the all system is on, and S0 states means all powers are on. Motherboard is fully on. It's called the power states. So normally that CPU send the 3 signals called S5, SLP S5, then SLP S4, and finally SLP S3. So this is a step number 3. And how much voltage will get here at that SIO? Will get here a 3 volt and 3 volt. If this 3 volt and 3 volt is coming on this SIO pin, SLP S3 and SLP S4, then the CPU is okay. CPU given the confirmation signal to turn on the powers. Okay, so you have to check that. So you'll get a 3 volt on the both SLP S3 and SLP S4. Now if this 3 volt is not coming here at SLP 3 and SLP S4 after 8 steps is completed, that means the CPU could be the faulty. So in that case you have to heat the CPU properly, or if the problem is not solved, you have to check all the signal. That is step number 6, that is called RTC VCC, RTC reset, RSM RST, VCC DSW. If all signals are okay but still SLP S3 and SLP S4 not generating by the CPU, that means the CPU could be the faulty. So you have to replace the CPU, right? So this is like that. So this is step number 9. Now this SLP S3 and SLP S4 is given to the SIO, and this both the signal is coming at this buck converter also. This SLP S4 is coming to this buck converter at step number 9 and turn on this particular power supply. Okay, this called VCC 1.35 voltage for the RAM voltage, called the VDD voltage, VDD, and this particular section for the RAM. Okay, this RAM supply turn on, and this is a 1.35 voltage, and one more that signal is generated, that is 0.67 volt. Okay, the next is after completing this voltage, this RAM section or this VDD section will generate the power grid. That power grid will come here, and this SLP S3 signal, here the SLP S3 signal also coming out from the CPU, and this SLP is going to the SIO, and that SLP S3 voltage is coming here also. SLP S3 voltage is coming here also at 1.5 voltage is turn on this 1.5, and SLP S3 voltage coming here also to turn on this 1.05. so that step number 11, this 1.05 comes out here, that is the system voltage, and 1.5 voltage also comes out here, right? And when this all voltage join together, they generate the power good like this, and all this power good is here, okay? And once this get the power good, it's called the run power, okay? The run power, okay, once it get, then this voltage will travel from here to here, then here to here, then 3.3 suspend and 3.5 volt suspend. That laptop comes on as 0 states now, okay? So it's like that. So we have completed step number 12. Then after step number 12, this run power, okay, is generated, and it generate little bit delay, and the next that signal that generate is VCCST power good. VCCST power good is given to the CPU. This signal is basically is called system power, okay, or system power good, or all power good normally in another laptop. System power, okay, or system power good, or all system power good, or VCCST power good, it means it's informing to the CPU that the all power rails are okay. Now you turn on CPU core voltage. CPU core voltage turn on CPU itself. But before this signal, he need this signal. So you have to check this signal. Okay, this is a 3 volt signal, VCCST underscore power good, step number 14. And then after step number 14, CPU generate step number 15 like this. It's called the VR on. Okay, this is my VR on section, CPU core section. Okay, so once CPU turn on this VR on signal, CPU core voltage will be generated. The core voltage is normally somewhere around 1 volt approximately. Okay, so you have to check this 1 volt approximately here, and this 1 volt is given to the CPU. This is called the CPU core voltage, right? Okay, and once the CPU core voltage gets stable, and then this VRM section will generate this power good section. See, this VRM section will generate the power good signal. The power good signal is called IMVP underscore power good. Step number 17. IMVP underscore power good. IMVP underscore power good means the CPU core voltage is stable now. Now you can process the next signal. Okay, so this signal get by the CPU. After receiving this signal IMVP power good, then the CPU generate the final signal is called the PLT reset, the platform reset. This very important signal, platform reset. This is a 3 volt signal again. So if this voltage is coming here, that means my step number 1 to step number 18 are perfect. Okay, so all power rails are perfect, all power supplies are stable and given to the different chips properly. So you have to check this signal, and after that CPU started communicating with the BIOS like that. So friends, in this way you have to follow these steps on the Wistron motherboard one after another. If you have a laptop in the Wistron motherboard and dead, so you have to follow this number, and 100% you can able to diagnose the problem in the motherboard. So thank you very much for watching this video.